I think the trouble here, you see, mathematics is full of all sorts of beautiful, deep theory, and most of mathematics as it exists now, in the sense of what's written in journals and so on, has almost no bearing on the physical world. Now, you see, I feel totally convinced, and I think you're expressing something similar, that if you find the right route through this stuff, you will really find the key to what we're seeing in the physical world. Now, we've found many such keys, and general relativity to the Lorentzian version of Riemannian.
To all your mother nature lovers, I want you to know, and all others, that I discovered the connections. All you gotta do, apply a digital root rule and the system numbers. We can start with a base 60, for example. It's not about how you count your fingers or how many knuckles you have and you come up with 60. I don't think that's what it is. I think all they did, they multiply and they add each number, and they got the digital root out of each equation, and they come up with this. You can pause and confirm what I'm talking about. That's a sexagesimal base 60, which has been discovered 5,000 years ago or more. The second thing I want to show you is a Fibonacci sequence number, which is really known to everybody pretty much these days. All I did, same thing, I applied a digital root rule and Fibonacci sequence number, as you know, 1, 1, 2, 3, 5, 8, 13, 21, 34. You go all the way down to infinity, you're still gonna get the same sequence. It repeats itself every 24. You can pause and check what I'm talking about. And I got more, which is the most important one, the Nikola Tesla, the 3, 6, and 9, which is gonna be next video. Thank you.
If they do need help, where can it come from? It doesn't seem that any of the chemists or the biologists would have enough to contribute, even though physics has contributed to both of those fields. And so the real hope is that it's either going to come from the theoretical physicists themselves, from mathematicians who struggle to make any kind of contact because the pedagogy in physics is quite forbidding. And I would say it's not quite as good as the pedagogy in mathematics, generally speaking. Or is it going to come from some completely strange source, maybe somebody who is a self-teacher off the grid that we've never heard of? But we've heard from all of the leading lights, and I would have to say that almost no one from the traditional community really has any kind of a great idea as to how to make the next project.
Okay, and this one over here, I'll explain what Nikola Tesla was talking about, the 3, 6, and 9. I know it sounds too good to be true, but if you, after you apply a digital root rule on a multiplication table, you get all these single digit numbers. And if you go like 9 units this way, they always add up to a 6, a digital root of 6, regardless of how high you go. All of them, they go 6 like this. And this way, it goes 3. All the numbers. And if you go like hashtag, up and down, left, right, you're gonna come up to 9. I'll have a different video explain it with a precise description. Thank you.
Botanists have noticed that plants seem to be fairly consistent when it comes to the angle between one leaf and the next. So let's see what you could do with that. So you grow your first leaf, and if you didn't change angle at all, then the next leaf you grow would be directly above it. So that's no good because it blocks all the light or something. You could go 180 degrees to have the next leaf directly opposite, which seems ideal, only once you go 180 again, the third leaf is right over the first. In fact, any fraction of a circle with a whole number as a base is going to have complete overlap after that number of turns, and unlike when you're doodling, as a plant, you're not smart enough to see you've gone all the way around and now should switch to adding things in between. If you try and postpone the overlap by making the fraction really small, you just get a ton of overlap in the beginning and waste all this space, which is complete.
We get back again to Fibonacci sequence number, which is I mentioned earlier or in a different video, that it repeats itself every 24, which makes sense. That's why we use the 24 hours a day. Wasn't a coincidence. It belonged to this sequence number. But 3, 6, and 9 always different, even in Fibonacci number, because it repeats itself, like 3, it repeats itself, the sequence repeats itself every 8, as you see. 3, 6, but 9 repeats itself every single time, which is, we all know why. So we start with the 1, 1. It's the same ratio of 2, 2, or 4, 4, 3, 3, but it has a different sequence and different single digital root. 24, 24, 24, 24, 24, 24, which is 1 is pretty much same as 8, 1, 1, 8, 8, because it repeats itself down here, just like repeat itself over here. 2, the same thing. 2, 2 is end up with it. When it comes to 12, a Fibonacci sequence number 12, it goes back to 7, 7. That's when you are under digital root rule. But 3, 3 comes back with the 8. As you see, 3, 3, 6, 9, 6, 6, 3, 9, 3, 3, still repeat itself on the 3 and 6. So 1, 2, and 4, which has been a mystery for a lot of people, why 1, 2, 4 comes up in a lot of number system and science particularly. So I hope that explained something, and I hope this will be a hint for something big, hopefully. Thank you.
When we look at nature, we see the complexities, the differences among things. But scientists tend to look for the connections, the simplicity that lies at the heart of it all.
The more you learn about nature, the simpler it looks. And that's why I think we will find a final theory. Because although I can imagine things getting infinitely more complicated, complication without end, I can't imagine simplicity without end. The whole progress of physics has been toward a more and more simple description of nature. And how simple can things get? Simplicity must finally terminate. There must be something so simple that we can't imagine anything more simple.